Captain's log, supplemental. When encountering the space beasts earlier today, I miscalculated the trajectory. What I didn't take into account was that when you find the time, you have to double it because the space beast must come down. It's not a mountain lion, it's a space beast. So you have to take into account the X and Y components. And once you do that, you can calculate the magnitude of the vector because we get Vx, Vy. If we know the two components of the vector, we can find the angle. Yes, let's do it. All right, let's read the problem, and I'm going to show you the correct way to do this problem. It is problem 3.31. Okay, so a running mountain lion can make a leap 10 meters long. So we'll start here and we will go 10 meters about, yay, there's 10 meters. And the mountain lion goes 3 meters high, and it's got a nice curved path like this, okay? So we've got a nice curved path there. Now, we know, so this is 3 meters, that's the height, 3 meters. The X velocity does not change. It is constant. That is something about two-dimensional motion that we need to be aware of and we need to take into account, because that means that Vx is the same over here as it is over here and up here. It never changes. There's no acceleration. We're not taking into account drag. And so Vx is always constant. We need to get Vx and Vy. Okay, and maybe I should have drawn Vx bigger. Vy does change. Vy is definitely going to change. We're going to have our initial y velocity. Down here at the bottom, it's going to be at a maximum. When we get to the top, up here at the height of our jump, Vy, the velocity of y is going to equal 0. Okay, over here, we don't know what it is. We can solve for it. So to do this problem, the way that I would do it, and this is how you do it, you have to solve how long does it take for the mountain lion to get to the top, and what was its initial velocity. Let me draw this a little bit better so that we can see our initial vector a little bit more clearly. Be a little bit more careful. So this is our x-axis. This is 10 meters over here. This is 0. So our initial velocity, our trajectory will look something like this. Well, it should be symmetric, but yeah, whatever. Okay, so we're going to have Vy going up this way. This is Vy, and then Vx will come out this way. So this will be Vx, and then our velocity vector initially is going to look like this. So this will be V. So this makes a triangle, okay? We can move Vy over here. We can move our vectors end to end. So Vy will be right there. And then once we have these, I'm going to draw those two vectors separately. Okay, so here is Vx, and Vy is going to be over here. Okay, this is Vy0. So now we have our velocity vector V. We have a triangle here, and what we're after is first in part A, the magnitude V, and then our angle theta right there. Okay, so we're given the height. We know that this is 3 meters. Okay, so that's 3 meters, and we can use that information to calculate our initial velocity. And we can use the equation of when it'll be Vy equals Vy0 plus 2ay. That's plus 2ay. Well, Vy up at the top is going to be equal to 0 because our velocity at the peak of our jump up here, Vy will equal 0. That means this term is going to go away. A is equal to minus 9.8 meters per second squared. This is negative because gravity is pointing down towards the center of the Earth. So what we end up with is Vy0 equals 2Gy, and I'm going to put G in negative 9.8. I'll bring it over there, and I'll get a negative sign. Okay, so I'm going to substitute in for A. So A will equal minus G, and I'll put that right in there. So G will equal 9.8 meters per second squared. It'll be negative, so I'll have minus G here. So I end up with this. Vy0 equals 2 times Gy. So my initial y velocity is going to be 2. And I think I already messed up. I did mess up. These should be squared. This should be v squared, vy squared. Okay, so our equation that we're using is vy squared is equal to Vy0 squared plus 2ay times y minus y0. We're going to write it out in all of its full glory. Y0 is equal to 0. That we're just going to say here. This is y0 equals 0 right there. Okay, so here's our equation. Vy at the top goes to 0. And we're going to solve for Vy0, okay? So we end up with, this should be a squared. So when we get Vy0, we're going to take the square root of 2 times 9.8 times 3 meters. And we got a meters per squared there. Okay, so we're going to plug that into Mathematica. So I will have 2 times 9.8 times 3. It's going to give me a number of 7.66812 meters per second. And I'm not going to put that in significant digits yet. I will wait until the end to do that because I do not want to lose anything. So that's going to give me Vy0 is equal to 7.66812. I'm going to keep these for now until the end, and then we can round them off later. The problem is if you start rounding off, then you get round off errors. The more you round off and then you calculate with that number, your errors get bigger. So we're going to wait till the end, and then we'll put in significant digits. The next part, we need to get our time. So we calculated our initial velocity. So the easiest way to get our the time is going to be to use this equation. So we're going to have Vy is equal to Vy0 plus AYT. This is to get time to peak. And this is important. This is where I messed up today earlier because this gives you the time it takes to reach the height of 3 meters, but you've still got to come down. So whatever you get for this time, that is the time it takes to go up to the peak right here. When you get to 3 meters, that's half your time. You still, the space beast has to come down here and land. So this time should be doubled. All right, so at the top here, Vy is of course going to be 0, so that just leaves us Vy0 plus AY times T. I'll put my numbers in for that. So I'll have Vy0 will minus, I'll put in 9.8 meters per second squared. That's a minus there, in case you were wondering. Times T equals 0. I'll bring my negative 9.8 over there, will become positive, and I have my number for Vy0 here. I'm going to put that in. Okay, so I'm going to end up with 7.66812 meters per second divided by 9.8 meters per second squared equals t. Okay, so I'm gonna bring this guy over here. We're gonna subtract, or we'll add 9.8 meters per second squared times t to both sides. This one will go away. And I'm running out of space here. Don't you know what? I knocked my camera. Oh, right. So this is gonna be half of our time of flight. Putting our numbers into Mathematica, we have 7 points. Actually, no, I'm just going to copy this because it actually is going to have a lot more digits. So see, Mathematica keeps track of them all, never loses them. Divided by 9.8, there's more digits, but we're not going to worry about that for now. So I get, for half of my time, t is going to equal 0.78 seconds. So t will equal 0.782461 seconds. And I'm leaving these digits in here. When I get to the end, then I'll put it into the right significant digits. So here's what we found so far. Our time is equal to 0.782461 seconds, and our Vy velocity is equal to 7.6682 meters per second. We're keeping these in there till the end so we don't get mistakes from our calculations. So now all that is left is to find Vy of x. And this is the time for half the distance. Okay, that means delta t is going to equal 2 times t. That's for the entire time of flight. That's where I messed up before. Okay, we're not going to make that mistake this time because literally 5 seconds after I turn off the camera, I was like, oh, obviously. Oh, well, it's much easier to think about it when you're not on camera. All right, now we have, let's draw our picture here. Our space beast is jumping. He's jumping. Maybe it's a she. Why does it have to be a male space beast? Here we go, 10 meters. And we know our distance. So now we're going to use the equation x equals vx times t. There's no acceleration. We know the time, we know the distance. Now we can get v of x. Okay, so our distance here is, to get v of x will equal x divided by t. I wanted to say t divided by x, but then I was like, no, our units are off. So Vx will equal 10 meters divided by our time, which is 2 times t. So it'll be 2 times 7.66812 meters per second. Okay, we're going to put that into Mathematica. Switching to math mode. There we go. We got it. You know what? We're just going to copy that right down there. See, that's the great thing if you have a calculator. So 10 meters divided by 2 times v. There we go. We're going to paste it in, and we're going to get rid of that. Okay. So that tells us that v of x, is that right? Something has gone afoul. Vx. Oh, what do you know? Oh, geez. That was supposed to be t. I copied the wrong thing. I put the velocity. Oh, Dr. Wisby, what? What are you doing? Oh, well, they're one's 0.78, the other one's 7.66. I mean, oh, all right. But the beauty, the power of Mathematica, there it is. Oh, we've done it. We've done it. The velocity is 6.3901. Let's see, we can continue with the digits. Let's write down what the calculator, what Mathematica gives us. Oh, there it is, 6.3900965. That's, oh geez, that's enough. Okay. we're going to throw away those significant digits later. But now we've done it. We found Vx, Vy. We can get the angle, and we can get the magnitude. All right, let us review. Vx is a vector that looks like this. Here's Vx, okay? Vy goes like this, and our vector is pointed this way. So there's Vy. There is our hypotenuse V. This is a right triangle. So we know Vy, Vx. So you should be thinking, that didn't work. That wasn't as dramatic as I thought. Not printing. You should not be thinking about printing. You should be thinking tangent. Yes. So we're going to have tangent is going to give us that angle. Then we've got a right triangle, so we can use the knowledge from our favorite cultist. That's right, the Pythagorean theorem. V squared is equal to Vx squared plus Vy squared. I'm trying to talk quickly because I want to make this video short. Then tangent of theta. Tan theta is going to equal Vy over Vx. We've done it. We've solved the problem. Hooray. So let us put the numbers in. I think you can do it, but I'm going to do it anyways. You can disregard this if you want to. Okay. Actually, you know what? I'm going to put in Mathematica, because why am I going to write here when I can write in Mathematica? Magnitude will then equal, and we're going to plug in the correct numbers. So for the magnitude, this is going to be Vx. We're going to square it. We've done it. Then Vy, we're going to grab the correct Vy. Doesn't fit on that line because we have way too many digits, which we're going to delete later, but we're going to keep it in there for now so we don't make some mistakes. Okay, here's the magnitude. Are we ready? Are we ready? Oh, push the wrong button. There it is. Our velocity is 9.98165, and we're going to use arctan. So arctan, there it is, arctangent of Vy over Vx. Let me grab Vy. Vy divided by Vx. I don't have to write all this stuff out. This is why we have computer, because we can copy and paste. We don't need to write it anymore. Okay, this is going to give us the answer in radians. So I'm going to multiply by 180 divided by pi, because you can't put Mathematica into degree mode. You can't do it. There, we've done it. Our velocity is 9.98 meters per second. We're going to round that off. Well, we can say, what the heck. So to summarize, V is going to equal 9.98 meters per second. Make it look a little better. Divided by meters per second. There it is. Then we're going to also say that theta is equal to 50.2 degrees. There are your answers. This is how to do it. Thank you for watching, and there will be more videos later, but I wanted to get that up there so that we did it the correct way. Remember, no, why do I keep hitting print? Remember, we found the time to the peak. Then we doubled it, because what goes up must come down. That is true. I can do it. See? It goes up, it comes down. Experimentally, we verified the theory of gravity. And I'm glad you asked, what is a theory? Gravity is just a theory. Remember that when you're watching the news and they say, oh, it's just a theory. Gravity is just a theory. So what goes up must come down. We confirm this. I threw my pen up in the air. So when we calculate the time to the top, we have to double it for it to come down. Then we found first we found the y velocity, then we found the time, then we use that to find v of x. Once we know the time, it's very easy. We just say x equals vx times t. That gives us, we solve for velocity. Then we use the Pythagorean theorem to find the magnitude of the velocity vector. Once we did that, we were thinking tangent. Everyone is thinking tangent. Tangent of theta equals vy over x. So we take arc sine of vy over vx. That gives us theta. We've done it. So that's all for now. I will see you on my next video or in class tomorrow, whichever comes sooner. Thanks for watching.
Thank you, like and subscribe down below.